When the input of your log is either a product, a quotient, or has an exponent, what we can do is expand that log and rewrite it so the inputs are simpler. With the product as the input, we can break it into its corresponding factors, and the expression becomes the sum of the logs of those factors. If it is a quotient, we can break it up with subtraction in a similar way. And if it's a power, something raised to a power, the power can actually come out front as a multiplier to the log. So these are three ways we can simplify log expressions. In particular, when we use them in this order, we can think about it as expanding the expressions, because you go from a single log over to two logs in these first two properties. And then you can think about this one's expanding because the expression gets a little bigger when you have the exponent out front. So let's do that in these two examples. Let's expand the expressions using these log properties. The first example, log of the quantity x times y cubed. The first thing to note is that that cube only applies to the y. So when we go to expand it, we must take into account the multiplication first and break it up with that addition rule. So log of x plus log of y cubed. So again, x and y cubed are multiplied, so we break it up into the sum of logs of those factors. Now, the next thing to do is to take care of that exponent. That 3, using this last property, can come out front, but only in front of this single second log expression. So what we're going to have is the log of x just remains, and the 3 comes out in front of log of y. All right, so that's expanding this first example. Notice in the end we end up with 2 logs instead of a single log. Let's try another one. Log of the fraction 1 over ab. All right, so because we have a fraction, we definitely have a quotient. So let's split up the quotient first. The log of the numerator, 1, minus the log of the denominator, ab. Next, let's use the log property for this product that we see for ab. So I'll keep log of 1 here, and then subtract. Now keep in mind we're going to be rewriting log of ab, not the minus. The minus just comes down. So this would be log of a plus log of b. But keep in mind that that doesn't involve the subtraction. So what you're really doing here is subtracting all of what that property gives you. Typically, we would distribute the negative. You could also just leave it in the brackets that I have in orange there. So I would distribute that as negative log of a minus log of b. And then I wanted to come back to this first expression and remind you of a log property that we've gone over in the past, and that is that log of 1, regardless of what the base is always 0. And that's because, remember, a log is just an exponential in disguise. That anytime we have a base raised to the 0 power, that's equal to 1. So this property actually comes from log rules. So this ends up being 0, and so our final answer here is negative log of a minus log of b. Let's do one more example. Here we still have the log properties listed. Our example is going to be log base 5 of 5 times x to the 7th all over the square root of y. So when we look at this expression, what we have is a fraction. So let's start with using this middle log property to break the fraction up. So log base 5 of the numerator minus log base 5 of the denominator. Next, we've got a product here, and we've got a power, and then technically the square root of y is a power as well, because a little reminder here, a square root is a 1/2 power. So this is y to the 1/2. So let's keep going on this. There's a product to take care of, and the product can be broken up with this sum rule. Log base 5 of 5 plus log base 5 of x to the 7th minus log base 5 of y to the 1/2. All right, next we've got the exponents that we could take care of. This 7 can come out front of the log base 5 of x. The 1/2 can come out front of the log base 5 of y. There is one more thing we can take care of. Log base 5 of 5. Anytime the base of your log is the same as the input, that is always going to be 1. Again, this comes from an exponential property. B to the first power is equal to b. So this is something that will always be true. And when you can, always simplify further with logs. So this first term becomes 1 plus 7, because we're taking the exponent out, log base 5 of x minus, oops, I forgot to bring the 1/2 out. So that should be a 1/2 log base 5 of y. I'll rewrite that just to make it look nice. So our final answer, 1 plus 7 times log base 5 of x minus 1/2 log base 5 of y, is our final result.